This is 6.6, part 2 of complex zeros. We were working on a problem where we're converting this problem to standard form. So to continue this problem, now let's go ahead and clean it up. Notice something's going to happen. These middle terms are going to cancel out. Notice I have a positive 2ix minus 3 and a negative 2ix minus 3. So what they do is they undo each other. They cancel each other out. We have a positive 2ix minus 3 and a negative 2x minus 3. So now what we're left with is just the green of the x minus 3 all squared, and then the red, negative 2i and times 2i. So let's work on the x minus 3 all squared. So remember that's x minus 3 and x minus 3, which is FOILing out x squared minus 3x plus 9. And then that red is negative 2i times 2i, which is negative 4i squared. Remember that when you have an I squared, that replaces it with a negative 1, or we said just drop the I squared and change the sign in front of the term. So it makes that a positive 4. Now let's go ahead and group like terms. So we have the function equals x squared, combine negative 3x and negative 3x is negative 6x, and then 9 plus 4 is 13. Remember, we started with two zeros, two complex zeros, and we ended up with a quadratic equation. We're going to go on to find the fourth degree polynomial giving these zeros, negative 1, and then 3i. So we'll go through some steps. So we know that there must be 4 zeros because it's a fourth degree polynomial. You don't need to write this first step down. It's just kind of explaining it. If they give you that it's a fourth degree polynomial and you have these zeros, you have a negative 1 and a negative 1, which is called a repeated zero, and then you have 3i. Notice there, that is a complex zero. So on that last set of problems, if you have 3i, then where must your other zero be? I'll let you go ahead and answer that in part B. Well, you must have a zero at negative 3i. It's conjugate. So now in part C, let's go ahead and write that in factored form. So remember, we think opposite. So we have 4 parentheses here. So go ahead and write the function of x equals, and now we're going to think opposite. So let's take care of the first zero. Well, that is negative 1. So we think opposite, x plus 1. We have another one at x plus 1. We have 3i, so that's x minus 3i, and then we have that last one, x plus 3i. Here it is in factored form. Now let's go ahead and convert it to standard form. So we're going to FOIL it out. I recommend that you FOIL out the first 2 parentheses because they're kind of alike, and the last 2 parentheses, then they're alike, and then combine those 2 together. So let's FOIL x plus 1 and x plus 1. So we get x squared plus 1x plus 1x plus 1. Then we'll FOIL the green, x minus 3, x minus 3. So we get x squared minus or plus 3ix minus 3ix and Negative 3i times 3i is negative 9i squared. Now let's reduce. So let's take care of the blue first. So we combine like terms there. We have a 1x and a 1x becomes 2x. And let's go over to the red. Notice the same thing happened on the last problem, where those middle terms cancel out. And that's common. When you multiply complex conjugates together, the middle terms will always cancel out. So cancel, cancel. Plus 3ix minus 3ix cancels out. So now we're left with x squared. Remember, I squared replaces it with negative 1, or drop the I squared and change the sign. So we get a plus 9. Now let's go ahead and multiply the blue and the red parentheses together. So let's distribute the x squared to x squared is x to the 4th. Then x squared to 9 is 9x squared. And then we'll distribute the 2x to the x squared, which is 2x cubed. And then 2x to the 9 is 18x. And then our last distribution is the 1. 1 times x squared is x squared. 1 times 9 is 9. Now let's go ahead and combine like terms so that it's now in standard form. So f of x equals, we have x to the 4th by itself, and then our next highest term is 2x cubed, and then we have a pair of like terms, 9x squared and x squared become 10x squared, and then we have 18x plus 9, a 4th degree polynomial function. Here is the assignment for section 6.6 on page 449. It's 1 through 3, 7 through 8, 11, 13, 20, and 22.